That's me in the lower right-hand corner of the slide presentation. I put that up there so people can recognize me if I do happen to shave my beard. It happened a few weeks ago where a guy that I'd been working with for a few days did not recognize me after a month because I showed up with the beard, and he talked to me for like 30 minutes before he realized that I'm the same dude. All right, today what we're going to focus on is the idea that virtual prototyping and virtual reality can help bridge a digital divide that's been created because of our actually being too good at digital modeling. Now, if you think about the classical product development timeline and value stream, as we go from product concepts all the way out to production and sales and marketing of our products, is that normally what would happen in a traditional product development phase is that we would recognize during the process engineering and process development if there were any things in a product design that made it difficult to assemble, difficult to build our products. We might have to go back to the drawing board and redesign or re-engineer the way we build these products. And as we go further along, as we start developing the tools or we start prototyping and piloting our manufacturing facilities, is that we have to go further and further back into our designs to try to fix the things that might have been missed. And terrible things that could happen is that if we actually go to production and our products actually go hit the market and we find something about that design that makes it inaccessible, unmanufacturable, unserviceable, and we try to go all the way back to product engineering, that's very, very expensive. And I know today we've been focusing on how computer design has really allowed people to do away with practical prototyping. That's a common theme when you come to these types of shows. People are like, digital engineering and digital manufacturing have allowed us to go away from having these practical prototypes, these practical proof builds of our actual tools. So, now they were talking about no more clay vehicles, no more wood models, no more prototypes, no more pilot plants, no more piloting facilities, proof tools, and that's been generally a good thing. However, that does mean that when we think about the way our products are evolving, is that we find that those product engineering tools that we use, computer-aided engineering, computer-aided modeling, allow us to deterministically find the problems that we know to look for. Like if I know to look for problems with certain boundary conditions for these modeling techniques, then I can find pass or fail that things are good, that things are bad. If I run an analysis, I can plug in a set of boundary conditions and find out if things are good or bad. So, we've been evolving from, man the tool maker, man the problem solver, to using computer-aided engineering, computer-aided tools to help us solve some of our problems. In the meantime, I did introduce the idea that sometimes we don't find the unknown unknowns. I can use computer-aided engineering and finite element analysis to find the things that I know to look for. I set up an analysis to find out what is the right design, right decision to make for the problems that I solve. But what we're introducing now is the idea that maybe VR is this next step in the evolution of man the problem solver, man the engineer tool maker, in order to find out the unknown unknowns, where we can explore and experience our products in order to find out what some of those issues are. So the idea is that we want to empower people to do virtual engineering in virtual reality during the engineering phase, so that we can give people an immersive, interactive, collaborative platform for them to solve their problems in integrating their products, virtual build, virtual manufacturing, and also virtual service, after-sales service of our products. That picture right there in the background, that is ICIDO, that is the product that I work for. And this is, the VR as it was normally consumed in the automotive industry for the past more than a decade, is that we would use power walls, we would use caves in order to do VR so that we could do a virtual assembly, virtual analysis of our products to solve some of those problems that we would normally have to hand assemble a prototype or proof vehicle to find out. So if we want to be effective in the way that VR helps us solve these problems, is that we really need to make sure that we address product behavior, process, and human factors, the people, using that in a collaborative, interactive way that takes into consideration how people will interact with their products in a very immersive way that is physically physically accurate. And so one of the things that I've already found myself saying is that we use computer-aided engineering tools to do away with physical prototypes. I should say we've done away with practically constructed physical prototypes. What we're introducing with VR and with ICI-Do is the idea that you can have a physically reliable digital prototype that behaves and you can interact with in a very physical, very meaningful way. So now once that prototype goes away and we start thinking about concurrent engineering, what we want to do is we want to help people use VR to do virtual product integration, virtual build, and virtual service of the products that they want to take to market. So first thing that I want to throw up there as an idea is, VR as a tool, and people talk about VR and AR as if it's just one thing. And the analogy I like to use is like if we roll back the clock and you remember when computers first started doing 8-bit to 16-bit to 64-bit color. And when somebody said to you, it's like, oh, I heard that, 64-bit color is now a thing. And apparently, you could use Microsoft Paint. That's maybe a multi-bit color tool. Can it do the same things that Photo Paint does? Because I heard it's also a color computer program. And right off the bat, people would say, no, you can't use Photoshop and Paint interchangeably. Now, I know there are people who have YouTube channels that would argue that, you can do the same thing. VR is very much the same kind of technology, that we don't want to use VR as just a single placeholder for all of these technologies, all of these tools that bring things to virtual reality, to immersion. So what I did is I created this little graph just to kind of show some of the differences, the differentiation between the different ways you might immersively try to look at your product in VR, plug it into your HMD, and experience your product designs. So I'm just doing a comparison between what we call virtual integration tools, game engines, pro visualization tools, or the CAD or DMU plugins that are available from a lot of the software packages you use today. On the side closest to me, this would be your left-hand side. On this side, we're considering how much time you have to invest before you get different levels of visualization fidelity, right? So at the very lowest end, you have this CAD visualization fidelity, right? So I can buy a plugin, and whether it's virtual integration or a game engine or a DMU plugin, I can get pretty much immediately, I can look at my product inside of an HMD, and I can see it with that CAD level of graphical fidelity. Now, if I invest a little bit more time, you'll see that the ProViz tools and the virtual integration tools can rapidly get you past textured or multi-material CAD. You can get up to this kind of CGI, computer graphics level quality. And then if you put a lot of time into it, maybe you could get up to this photorealistic level of quality. Right? Now, if you think about what happens with game engines or maybe some of these CAD DMU plugins, is that it takes a lot more time investment to get that same level of visual fidelity. If you want to get photorealistic visualization out of a game engine, it takes a little bit more time to get that same level of quality that you might invest. On the other hand side, we have the interaction. If you want this VR to be interactive, then what we find is that in those dashed lines, virtual integration tools can rapidly bring you into an immersive environment, give you reasonable visualization fidelity, and also give you the ability to interact with your product in a very physical, meaningful way. Now, it's a little bit more of a challenge for now the ProViz tools that were really focused and put all their technology into making beautiful photorealistic renderings. And then how do I add physics to it, multi-body physics, solid mechanics? And that's been a challenge for the people coming out of the ProViz space, right? So I could invest a lot of time in that, and eventually I might be able to get to the point where I can make some preconceived, pre-canned animations, but maybe I'm not even getting predefined behavior, and certainly not quite real-time interaction. Now, of course, game engines are excellent at this, right? If you have a game engine, you can see that's kind of a linear progression. As I put more time into it, I can get a certain level of fidelity out of it. But the real challenge is if I want to apply these tools to the idea of doing engineering decisions, is that I really need to be in the sweet spot of being able to make decisions when they were important. I need that reasonable level of visual fidelity at the same time that I also have this ability to interact with it in reality. And we don't want to necessarily use these tools that take a long time to reach that interactive capability to try to drive engineering decisions because, well, I'm fundamentally back in the world where I had practical prototypes, where I was investing a lot of time in building a hard model. And so VR is supposed to take the place of that hard model, so I should be able to get there pretty quickly. So this is just a little animation I make, and I apologize. I mean, I was watching everybody else's videos. They had such beautiful videos. My videos are pretty hackneyed. That's my GoPro camera taking a video of one of the kids on my robotics team. And this is a VR model that I had taken the day that they announced First Robotics Challenge this year. How many of you know about First Robotics? Right, so in January, they announced what the new game is, and they released the CAD data of what the game field looks like. Within less than an hour of when they released that CAD data, I was able to download that CAD data and put it into our application, and now I was letting the team members tour the field in VR so that they could use that to guide how they were going to design their robots. And this was something that we were able to achieve very quickly, the same day, the same hour that we got that CAD data up. And that meant that we could start making informed decisions about how to design better. So when we talk about the product development journey and where I like to focus, this idea of digital virtual integration is right here in that sweet spot, highlighted digital virtual integration. There certainly are great VR tools that are great for being digital virtual clays, digital product styling developments. That's one way of using that technology of VR and immersion. Also, back on the other end, you can see virtual training, virtual operations, virtual sales and marketing, what I like to think of as persistent VR experiences, where if I have to invest a lot more time for a persistent experience, that's cool too, right? That's up to them. But where we need to be to feed this product engineering, process engineering, and tooling development phase is in that really rapid iteration, rapid change environment of being able to make decisions and evaluations at the point that I make a decision. As soon as I design a new idea, I have to be able to experience it. I have to be able to let my team members experience it and make a new decision and then see how that decision influences the rest of my design. So one area that's a challenge for us is this idea of product integration, space claim and packaging. So we want to use VR to make these decisions. And when we're talking about integration challenges, we have to think about the size and the complexities of many of these models. So we're talking about very large models, millions and millions of polygons of complex models that we want to be able to integrate with each other that are chances are coming from different CAD systems, different engineers, different designers, and I want to integrate the product and the environment and the behavior, the processes of putting that product together. All right, so this is just an animated GIF of one of our customers doing a axle validation, and what they did is they integrated all of the moving bits and the moving parts of this steering assembly for the front of the car, and what we're looking at is a travel of the suspension relative to all the hoses and the wires and the cables that go into that device, into that system. And the thing is that when you think about what engineers do, we draw all of our pictures in end position, or maybe we show them in one extreme or the other. But in fact, there's an infinite number of different combinations of positions of that assembly, and we want to make sure that those hoses and wires are appropriate and they're the right length. So our customers are using VR so that they can bring that CAD data in, they can make it behave physically like the product's going to in the end use, and they go into VR and they grab onto that thing and they shake it up and down and they turn it left and right to see if those hoses are in fact going to pinch or bind or cause any problems. Another challenge is occupant packaging, visibility, accessibility, and utility. So you want to use VR for that so that people can actually experience their products. So in this example, we have people using virtual reality, in this case, a mixed reality situation where they have a projector doing projected VR, and they're reaching through with those little hand things what they used to do with wooden models. So this is a customer of ours, Bausch and Strobel, that used to use wooden models to mock up all of their layouts. And every time they would try a new layout, someone would have to take the carpentry team and cut that thing apart and put it together and try it again in another configuration. But with VR, we could actually just load in new data or move that data in space and try it out a different way. So that allows us to use VR to minimize the risk that we have in product design by evaluating the decisions that we make for all of those downstream effects. We can evaluate our product, the process, and how people interact with our product during those processes, where that process might be everyday use, it might be assembly, and it might be even service after sales. So here's a couple examples of people using VR. In this case right there, the young lady at the top, she's loading a battery into the back of a hybrid vehicle. And what she's finding out is that the tooling that was envisioned for loading that battery into the back made it more difficult for her to even see inside the trunk whether or not she was clearing it. And that was something that was validated using VR. So these are some more examples that we have here of where we're trying to now use VR to merge the first-person experience that we have with our products with the third-person experience that you have with a mannequin. So what we're able to do in VR in this case is that we could record motions that a person was doing in VR, and we could map those same motions to a digital mannequin. So this is a mannequin that we're introducing. This is the Human Solutions Ramses mannequin, and we're able to capture our virtual reality behaviors and the virtual reality physics and play that back through the mannequin so that we can see if I did some action from my point of view, what would that look like for different size people, for different populations, throughout the wide range of databases that are available for people to use. In this case, you could use VR to see whether or not the tools that I would use to loosen a bolt in this engine assembly would in fact cause collision with any of the hoses and the other assemblies inside that area. And you could see when that wrench moves up and down, you can see that we're doing real-time collision handling and collision detection and even elastic motion of those hoses to see what can fit and what won't fit when we try to service that car. All right. And here again is another HMD example. This is me doing some service procedures on a Volkswagen Passat, trying to change the headlamp enclosure. In this case, I'm trying to service the exhaust. And I'm going to even try to see if that tool can in fact fit up a little bit higher up into that assembly to try to get that last bolt. And in this case, no, I can't get that wrench up there for that last bolt. Here we are attaching and detaching a sensor to the exhaust assembly and trying to see, can my hand tools get in there for the right amount of work? So where we try to apply virtual reality to engineering is really at this confluence of product, the people, and the processes that make up our product as we try to bring it to market. All right, so the last thing I'll show you is this, the evolution of mankind, the tool maker, the problem solver. Well, I want to get that wire to go away for VR. So this is something that we were able to show at the GTC in Europe. You guys are the first people in North America, hopefully, to be talking to someone while we do this live. This is a video that I took live where we were streaming a virtual reality review from a laptop computer over a wireless signal to, that's my Samsung Galaxy 8 phone. Sorry about my shaky hands there, a little bit more stable here. But we are actually streaming the VR experience, omnidirectional 360 view, to that phone so that people could have VR experiences wirelessly. And that's it.